Welcome to this Multiplayer Hub presentation, Simulated Players for Scavengers, the hard-working bots that required a lot of hard work. My name is Terry Drummond, and I'm a partner engineer at Improbable, which means that I work very closely with game studios to build cool technology and connect it to their games. Today, I'll be telling you all about the artificial intelligence players that we built to help us with testing the game Scavengers by Midwinter Entertainment. Scavengers is a multiplayer survival game set in a huge frozen battleground that's infested with monsters. It's free to play, so you should check it out. In Scavengers, groups of 60 players must explore the world, scavenge for better gear, and fight against AI enemies and other players in order to survive and make it off the planet alive. To build a game like this, you have to be able to test a game like this. You have to test it over and over. So one of the things that my team did was build AI players to help us with that huge task. Before I get into the details, let's get us all on the same page. I'll outline what a simulated player is. A simulated player is an AI behavior replacement for human input. It runs as its own client process, so this is different than an AI companion you might see in a game, or an AI enemy, which would typically have their logic running on the server. Simulated players run their AI logic on their own game client, and this is important because it lets us fully emulate what it is like to have a real client connected to a game server, providing input and playing a game. In terms of what a simulated player could actually do, it could be anything that you want. You could have them do totally randomized or chaotic actions. You could have a simulated player do a deterministic set of actions, that is to say, every single time their inputs will play out exactly the same. Or you could do something fancy, like build up an AI that has them react to the game state around them, or play through the game mode as a cohesive team. Now, the main moral of the story of simulated players for Scavengers that I want to convey to you today is that making very basic bots, or basic simulated players, is pretty easy. Making competent bots and maintaining them over the course of a game that is also being built on a tech stack that is shifting is a hard problem to solve. But with the right recipe, all of that effort will be really well worth it, and you'll be rewarded with a powerful tool for developers and an excellent complement to your existing testing practices. Now I'm going to run you through how we built our simulated players for Scavengers, how we got our bot buddies lootin' and shootin'. This might sound a bit cheesy, but I want to make sure that I first call out my appreciation for everyone at Improbable who helped with the process of building simulated players. It's taken a lot of work from a bunch of different directions. It's not just the development of their AI that my team worked on, but all of the work that goes into standing them up with our online services, incorporating them in playtests, doing telemetry analysis to validate their behavior. Everybody on this slide contributed in one way or another, and it really did take an army of humans to build an army of bots. When we first decided to build simulated players, we had two key problems that we needed to solve. Looking back to February or March 2020, back when we were all together in the office, we looked like these cats here. We were frenzily playing Scavengers, 30 or more of us, all the time, because we had rare, hard-to-reproduce bugs that could only be found, or if we had a fix for these bugs, we could only validate the fix by playing this way, having this many people playtest repeatedly. Even with the help of QA, this really wasn't sustainable. We also didn't have a great way to measure the performance of the game. So if we wanted to iterate on anything that could potentially improve the performance by making changes and then measuring the difference, the only way to do it was to have this many people playtesting. At this time, one match of Scavengers held 30 people, but we knew we wanted to raise that count to 60 eventually, so it was clear that it wouldn't be sustainable to gather 60 people for this type of iteration. Based on this situation, we came up with a set of goals for our simulated player tech to achieve. The first one was that simulated players should create representative load on the server. And so this means that a certain number of simulated players playing the game should generate load on the server that is similar to the same number of humans playing the game. Testing with simulated players also had to be repeatable. So if we're testing over and over, especially in the case of trying to test performance, the results should be similar each time. This is important to call out as a goal because games have many elements of randomness to keep the gameplay fresh, but we want our test results to be relatively consistent. We also needed to repro these crazy bugs that we were seeing, so the behavior that sim players did had to be close enough to what human players were doing so that we could at least hit common cases that were causing our crashes. Ideally, a dev playing with some simulated players in tow could hit these crashes and check their fixes all on their own, without needing a bunch of people to help them playtest. And because these problems were consuming a lot of staff time with testing, it was really urgent that we had this working. So another requirement was that we had them ready to be used quickly and dirtily if necessary. We also had a couple of anti-goals that we've maintained all the way through the development of simulated players. They're not meant to look smart, and they're not meant to be fun to play with. They were never meant to be something that people playing Scavengers would see. They're only meant to be a tool to help developers with building and testing the game. Now that we've got those goals, how did we build them? Quickly and dirtily, just like our plan. We got a head start by reusing the AI behavior trees that were already in Scavengers for the enemy combat logic. Everything else that couldn't be reused and had to be made from scratch were things that only players were expected to do, like picking items up off the ground, looting chests, or going to certain locations across the map. 3 developers on our team split up that work, and within 2 weeks they were able to get all of the basic behaviors stood up, which was a really impressive turnaround. Now, even though we got most of the behaviors working in only 2 weeks, it took a couple more weeks after that to fix the biggest problems with the simulated players. And that was that they would get stuck really easily. They were getting stuck for a bunch of different reasons. Sometimes they found their way into some strange geometry in the world. Sometimes they were trying to get items that were just out of their reach, and they were trying to grab them and they couldn't. Or sometimes they got into an edge case in their behavior logic that we didn't account for, and we'd have to patch them up. To give you an idea of the sort of things that we were looking at, I've got a couple of videos here. In this case, you can see the simulated players are just standing still, looking up at the ceiling and not moving at all. And when I ran up to the roof and I grabbed these items that they were looking at, they actually unstuck their behavior real quickly. Unstuck. But by the time I get back down there, they've already run off to do something else. One more example here is a couple that are stuck looking at a wall very intensely, and there's an item or something in this closet behind them that they think they should be able to grab because they're close enough, but because of the wall in the way, they can't. These are just a couple of examples, but there were all sorts of things that would get them into this situation. But we did get most of these solved, and the simulated players are in a pretty great state now. One of the things that I was worried about once we had the simulated players up and running was, how are we going to maintain them over the many months before Scavengers ships, because the game was going through some rapid development and changing quite a bit. But it actually turned out that the game itself changing wasn't the biggest issue with keeping the simulated players up and running. The biggest challenge was actually keeping up with the rapid changes to the online services and the changing tech stack. Over the following few months, the Scavengers tech stack went through some huge changes. We went from running on what's called the classic Spatial OS platform to a new and improved platform called the Scavengers Viable platform. The build system changed from Jenkins to BuildKite. Player data storage of all the information specific to individual players changed from PlayFab to our own new system called Scavengers Data API. And some other important tools, such as Game Studio Server and our new lobby services came online, along with new tools for deploying and testing servers too. With each of these changes, we had to adapt bits of the simulated players, because they ran through this full tech stack of being built, being deployed as headless Linux clients that we'd run en masse in the cloud, connecting to the lobby, logging in, joining a queue, and then playing through a game. I put together this timeline, and I'm not going to go through it all, but what I wanted to convey with this is how rapidly we encountered regressions, and we're also seeing improvements as the tech stack was maturing from August to September in 2020. The sorts of things we were hitting were sometimes bugs in this tech stack, but often just usability issues where our rapidly changing tools temporarily weren't easy to use, or had unclear error messages that prevented us from launching up our simulated players the way that we expected. Just to give you an example, a really early problem we saw was that a user was trying to test with simulated players and entered the launch parameter svp-test, when the expected parameter was just the word test. And there was no user-facing way for this person to tell why nothing was working. Nowadays, this problem never happens, because we've got a great system that autofills all of these important fields, and a user just needs to do a couple of clicks and they'll have a match running with simulated players in no time. A couple of other really notable developments happened in this time period too. At one point, all of our logging came online, nicely organized and uploaded to cloud storage, so that after running a match, a developer could easily grab the logs from the server and all of the simulated player clients. Another cool improvement was an optimization to how we built textures for the simulated players, which massively decreased the file size and brought the time for launching a match of them from about 14 minutes all the way down to only 2 minutes. Now, I've got a few clips of what simulated players look like today. Well, not today. These clips are a bit old, but you get to look behind the curtain at some early game footage. This one right here is a stress test of running 11 simulated player clients on one Windows machine. They're opening up a bunch of chests and equipping gear, they're using their abilities, and sometimes they punch each other. They're just kind of running around having a good time. And with this sort of test, we can see the major things that we expect of them. This clip starts off with this jumpy boy. I love him. We expect the sim players to be able to jump, crouch, and shoot and use their abilities, and move throughout the world without ever getting stuck. Or at least if they do, it's pretty rare. They'll also pick up points from these key locations like this one, this kind of gnarly shard location here. They'll pick up any of the data points that fall on the ground, and they'll also pick up other items and consumables, and use them too, like you have to do in Scavengers to keep your stamina up. Another interesting development that we had come in a lot later in our process was that wherever they are in the world, the simulated players will stop what they're doing and run to the dropship as it comes down. This is an interesting case that I want to highlight because for quite a long time we didn't have this feature in the sim player's behavior. We hadn't prioritized it because we didn't think it would help us generate representative load on the server or reproduce any particular bugs. But at one point in the game's development, we did hit a case where we had to do another one of those frantic playtesting sessions to try and figure out a weird bug. And the bug ended up being something to do with the little red map dots that appear in the top left corner of the screen. And you only get a lot of those map dots when a lot of players get together in one place, which typically happens when you're running to the dropship. The bug had to do with there being too many of those. And now we know we need to have the simulated players run to the dropship to really hit all of our testing cases. You can see there they all are, waiting to get inside. On the map, they're all bunched up together, and you can even see that they picked up some points during this test that I ran as well. So here again is that list of everything that we expect them to do. And like I mentioned before about our anti-goals, we don't expect the sim players to do things that make them look cool, or anything that doesn't strongly contribute to our original goals of producing representative load on the server, having repeatable tests, or reproducing common bugs. So more complicated tasks, such as repairing and driving vehicles, crafting items, sliding down hills, or strategizing in battle, we get around those by letting the sim players use some cheats, and that just makes our lives a bit easier. Alright, so we've got our simulated players working, we've got them running on the full tech stack, but how do we know that they're consistently doing what we think they should be doing, and actually generating that representative load on the server? How can we validate that behavior? We've done a couple of studies over time which compared a bunch of telemetry from human players playing matches to simulated players playing matches on the exact same build. From this study in July 2020, it was found that the simulated players actually exerted more load on the servers than the same number of humans did. We were wondering why that was, because it looked like both the sim player matches and the human matches had the same number of AI enemies running around. We saw that the human players tended to die over time, whereas the simulated players didn't die because they've got some cheats that help them out. So the increased number of active players in the sim player matches likely contributed to that increased load. Our main hypothesis, though, was that based on the movement patterns that we saw, in these two maps on the right, you can see that the human players spent a lot more of their time in the empty wildernesses of the Scavengers map, whereas the bots tended to stay in the encounter locations where there's a lot more going on. Because the simulated players seemed to be producing load on the server that looked like a worst case scenario, and we knew how big that difference was between a sim player match and a human match, we were able to consider the performance of the sim players representative. Another study was done during a big playtest that happened in November. If you look at these graphs on the right, the top graph is data from the main server worker, and the bottom graph is for the offload server worker, on which all of the AI enemy logic runs in the game. For a bit of context, this setup uses another cool piece of tech at Improbable, where we can run certain aspects of the game on a separate server process to achieve an overall better player experience. What to look out for with these two graphs is that the bright blue line represents the server frame time on matches played by humans, from the 25th percentile to the 99th percentile. The steep incline of this line shows us that the variability between the quickest frame times and the longest frame times is quite high in matches played by humans. The green lines are data from matches played by sim players, and they have a shallower curve, which shows us that the server frame time is less variable when simulated players are playing a match. We think that this might be due to, again, human players dying and dropping off during a match, so we can adjust our expectations of the load that simulated players generate around this. We can also see that the fit of the lines between the 75th percentile and the 95th percentile was quite good. The slope is quite similar, and this means that we can consider this load representative of human players and can use this data for these percentiles when looking at performance. The third tool that we use to help us validate sim players is a test that runs the sim players through a match on our latest build every night. It automatically emails us a report about what the sim players did and what the server performance looked like. In the report, we also get all of the crashes that happened, and the logs from the sim players too, and this helps us identify newly introduced issues. We also get a map of everywhere that the sim players moved during the course of the match, and some further info such as how many AI were spawned and killed, and how many players were killed, and this helps us make sure at a glance that the sim players are continuing to play the game the way that we expect them to. Because this information comes from the same telemetry system that runs when humans play matches, we could potentially add in any more information that we want to track, or do some comparisons to check how sim players are playing in comparison to humans playing. Alright, we've got our sim players and we've validated them, and now I'm excited to talk about how we've actually used them to great success. The feedback that I've gotten from other teams that have used simulated players over time is that the original goals that we had have been achieved pretty well. With the load being representative, the tests being repeatable, and being able to automate this system, we've been able to achieve the iteration that we needed. Our runtime optimizations team used the sim players when iterating on performance improvements, back when we were working on supporting an increased player count from 30 to 45 and again to 60. Another team, which had the fun name of Hope Our Running System's Efficient Yeah, or shortened to Horsey, was validating performance at a later point, and they also found sim players really helpful for that task. And the quality assurance team, the Midwinter team, and my team of game solutions engineers have used the simulated players quite a bit to pad out human playtests with additional load, and to hunt down those tricky bugs that only happen at a very low rate, or when a lot of players are in a match. I want to highlight a powerful workflow for developers that I am super excited about, and that I've personally used a lot while working on Scavengers. A common problem that we see is, there's a low repro crash and we don't know what's causing it, or I have a fix for a low repro crash, but I'm not 100% sure it's going to work. In the before time, without simulated players, all you could do was submit your fix blindly, or put in some additional logging, and then wait days to see if the bug surfaced again, or request a bunch of people to help you playtest. But now, with simulated players, you can create a build with your fix included without having to actually submit the fix to the codebase. Then you can spin up a sim players match and sit back and relax while the bots play several games, and all the while they will generate the logging for you, as well as any crash reports. Using this workflow, with only about 5 minutes of hands-on effort, one dev can playtest as if they were 60 people, to a pretty good effect. I've used this a lot myself when we're looking for weird regressions that can happen when we're doing big pushes to the Scavengers codebase, such as when updating the Unreal Engine version, or when updating Scavengers with a new version of the Spatial OS GDK. I remember I ran several simulated players tests while sitting in an all-hands meeting, just letting them test for me. This workflow can also be combined with another Improbable tool called Playtest HUB, which caches game builds locally and lets you download different builds of a game really quickly by reusing everything that hasn't changed in the cache. So if you need to jump in alongside the sim players to look for a more qualitative bug, such as a visual issue or the feel of character movement, you can have your own Windows client ready to play with them in just a couple of minutes. I actually used this method myself at one point to test 11 different builds back to back, looking for a specific bug, and I was able to download each of these several gigabyte builds in just a couple of minutes each on my very underpowered home internet, and I could test with a full set of players as often as I needed. Great, so where can we go next with this technology? I have a couple of ideas, and a couple of growth opportunities that I'm interested in, and I'm also eager to hear from other devs in the industry about what sorts of problems they might be able to solve with a setup like this. In terms of technical improvements, we'd love to get sim players running in an automated way on machines with GPUs so that we can track client performance. Right now, they only run as headless Linux clients in the cloud in an automated way, which is meeting our needs for gathering metrics about server performance, at least. We're also planning to run specific testing scenarios during our team playtests by adding sim players into a match alongside humans and turning on specific sets of behavior that help stress test the game. For example, we could run a command in a live game that gives all the sim players a specific grenade and infinite ammo, and we can check exactly how game performance is affected if they all start throwing the grenade over and over. I made this slide wishing that the sim players would give us their full crash dumps within their crash reports to help us debug, and I just heard today that this is nearly ready to come online, so that's exciting. I'd also love to see this sort of tech help other game teams. The SimPlayer AI that we've built here is quite specific to Scavengers, but we've learned a lot through this process, and I'm eager to help other game teams get set up with tech like this to meet their specific needs. As someone who's worked on a team making multiplayer games in the past, I know that I would have loved to have a combo of SimPlayers, Playtest HUB, and this nightly testing framework to help me out. And that's everything I have to share for now. I hope you've enjoyed this talk. If you're interested in SimPlayers or best practices when making multiplayer games, please reach out. Let's keep chatting.